Okay, so for the people who are not here, I'm just going to repeat what I said. So today's day one of our class, MCR 3U. This is the first of the 1 hour, minimum 1 hour Zoom sessions. And basically, we're going to cover what we can cover in 1 hour, and you're going to have to do the rest on your own. But what we're doing is I have a YouTube videos under content. Okay. And it's going to be what we are having to do today. On my screen, it shows a little bit more. On your screen, it only shows less. So we're going to go through, and then there's also a PDF of the actual lesson that goes with the YouTube, which I will go through with you guys and better explain. After the lesson is done, then we have assignments, which are just worksheets, by the way. I shouldn't say like assignments, like they don't count for marks, okay? But they're worksheets to practice so you know what you're doing, okay? And the way it works, if you wanna get the step-by-step answers, submit, I see your hands raised, let me get to that. Submit your worksheets in the section provided. So you can see there's 2 worksheets for today. And I'll give you the step-by-step answers. The worksheets you do will have the final answers at the end, but if you want to see the step-by-step answers, maybe you're stuck, okay? I can submit that at the very end, okay? Once you submit, I will reply with the step-by-step answers. I can't just give you the step-by-step answers unless I see you do some work, okay? So let us get at it. Before I stop sharing, let me see who's here. Who is 167648? Who's that? I need to know. It says, okay. You have to put your name. I don't know what is, okay. Yeah, so make sure you change that in your screen display, okay? Do you change that now? Number 167648. Okay, so let us start. I guess I'll do like this so I can better see. Okay, I can better see that way. Okay, so let us start with the land acknowledgement. We acknowledge we are hosting the lands of Mississauga of the Anishinaabe and the Haudenosaunee Confederacy and the Wendat. We recognize the enduring presence of all Métis, First Nations, and Inuit people. Okay, so today started at 10:30. I apologize. Next week we'll start at 9. There's things happening that it's on my control for myself, so we're gonna have to start at 10:30. If you can't make it, you know I'm recording it, but it's best, as I said in the orientation, it's best to always, if you can, if whatever happens, maybe you have a doctor's appointment, dentist appointment, but if you can, please make it to the online Zoom sessions. Okay, so someone asked me about the grades. I don't want to get into that. We'll get into that because it's due. It's going to be due. Oh, I think you'll see your mark because you have 2 tries, but I don't think I will release the answers for everybody, right? I think you see your mark. I believe so. Okay, there's one thing to see your mark versus the one thing, you know, everyone sees the final answer. Okay. And you get 2 tries. Okay, let's get on. I'm gonna go into. Yeah, you see mark after you complete it. Okay, so now we're gonna move on because we got to get into what we need to get done here. And people are coming in as we speak. So let's go to the content section. Okay, so from your point of view, you can see we're doing lesson 1. Actually, let me go back to the home page. Oh, we got a visitor. You wanna say anything before?
Just a quick welcome, that's it. Is that okay?
Yeah, it's fine.
Okay, good morning. Good morning, students. My name is Mr. Alvey. I'm one of the program administrators responsible for math for East Summer. Just wanted to wish you all the best. Enjoy the course. You have a great teacher. Things should be good. If you have any questions for me, just send me an email and I'm happy to respond. Other than that, have a great day and a great month. Thank you.
Okay, thanks. Okay, and his email was in the chat there if you want to see. He's the VP or one of the VPs. Okay, so if you have any other issues that beyond that I can help, you can email him. Okay, so today let's get into it. Today we're going to talk about definition of a function, function notations, investigate domain and range, and there's a quiz. The quiz I think is already released, but don't worry about that now. Let's get into the lesson. So the lessons are in the content, as I talked about in orientation. We go to here. You can see when I click on that, that is the Word document. I don't know why it's not showing on the screen. Takes a while, maybe. There you go, it's loading up. So this is the lesson 1 we're going to go through. That's the Word document, but instead of me just talking it through, I have a video that goes with this that lesson, and we're going to go through that together, where I'll pause in between to emphasize things, and if things need to be clear. Okay, so here we go. And let me know if you can hear it. I need to. Can you guys hear?
No, I can't hear anything.
Okay, so let me fix that. Let's try it again. Can you hear now?
No.
Okay, give me a second, guys. Can you guys hear it now?
No.
Let's see here. Did you guys hear that?
No.
Oh, That's interesting. I can hear it on my end. That's why it's very interesting. You guys can't hear it. Wow. Give me a second. It's weird you guys can't hear it. Okay, hold on, guys. That is weird. I'm gonna pause the recording, but it's gonna seem like it's going longer than it should. Yeah, okay, you're right. You know what? Sometimes you've done this for so long and you haven't done it for a while, then you forget. So give me a second. I probably didn't do the sound sharing. And there you go. Sound sharing now. So you should hear it now.
Relation is most simply put a pattern.
Okay, did you guys hear it?
Yeah, I can hear now.
Okay, good. When you haven't done Zoom for a while, you forget things. Okay, so let's go back to the beginning. So we're going to be talking about functions, domain, and range. Okay, that's what we're talking about today. So let's get at it.
Here's the first lesson for the grade 11 functions course. In this lesson, what we're going to do is look at first the difference between a relation and a function. Next, we're going to learn how to use the vertical line test to determine if a relation is a function or not. And lastly, we're going to learn how to state the domain and range of a relation. So, start off with what's the difference between a relation and a function. So first things first, let's get the definitions out of the way. A relation is most simply put a pattern between two variables. We can represent this pattern using ordered pairs, table of values, graph, and equation, and you would have seen relations described this way all throughout your math career. So next thing we're going to do is be able to determine whether a relation is a function or not. So what is a function? A function is a special type of relation in which each value of the independent variable, x, corresponds to exactly one value of the dependent variable, y. More simply put, for a relation, so if we look right here, for a relation to be a function, there must only be one y value that corresponds to a given x value. That's the most simply put definition there. For a relation to be a function, there must only be one y value.
Okay, so that is very simple. Let me just get into an annotation here. I want to kind of fast forward. Okay, so you guys can see my little graph there, right? Okay, so if I have, this is my y, this is my x, and if I draw a line, I'm going to make this color purple. And if I go like that, for every x, there's one y. Okay. For every x, there's only one y. Okay. And that is what we're saying here. Now, that's a linear relation. Okay. Now, if I draw a parabola, because you guys are familiar with that. For every x, there's only one y. Right? For every x, there's only one y. So that's a relation. It's a relation, but it's a function. Okay. Now, here's something that you see that's not a function. If I draw, say, a parabola like this. No, it's not a function. And they have this thing called vertical line test. If I draw a line vertically right across, if there is two y values for one x, so here's my x over here. I have two y values. So it's not a function. Okay, that's the simplest way, right? If there's only one y value for every x, then it's a function. It could be a relation, but that's what we're looking at. We're looking at if it's a function, okay? So that is the idea. What's he talking about?
That corresponds to a given x value. And we're going to look at a few examples represented in all of these different ways to be able to tell if there's only one y value for a given x value, to be able to determine if a relation is a function or not. And I also put a little note here, just for you to know that all functions are relations, but not all relations are functions. Functions are special types of relations where there's only one y value that corresponds to a given x value. So let's look.
Okay, so look at this one here. I'm going to fast forward certain things. Okay, this one here, the question is complete the following tables for each relation. Okay, it's done. Now, which one is between these two? They're both relations, right? Because one equals to something is a relation, but is it a function, right? If I look at this, if I look at this column here, 9, is there one y value? Okay. Oh, but I go down here, y, there's another y value. If I click on 4, 4 has 2 y values, -2 and 2. So it's not a function. Okay. Now, if I look at this one over here, you guys can see my mouse, right? I just want to make sure you guys can see my mouse.
Yeah.
Okay, okay, good. So you can see here, -3, and I only have 1x, or sorry, -3, and I have 1 y for that. -2, and I have a y. There's nothing repeating as far as for every x, there's only one y value. Okay. We're over here. I have an x, but I have 2 different y values, 9, and then I have a -3 and a 3. So this is not, and if you were to draw this, if you were to draw that on a graph, it would look like a parabola that's like this. Okay. And a parabola is like this. And you can see if I were to do a vertical line test, which is just drawing a line down the middle, or not down the middle, just vertically. Okay. And if this is an x value here, you can see I have the line hits up there and it hits down here. So for a given x, there's 2 y values. Okay. So it doesn't work. So let's kind of fast forward that. He's going to explain that. But I want to get into the meat and potatoes for some things. So there you go. That's what he's showing you here. And you can see, by the way, this video is inside Brightspace, but I'm just kind of paraphrasing it so we can go quicker. And also you guys can watch the video and as I explain things. So this is obviously it's a relation, but it's not a function. Okay.
Mr. O'Debbie, I have a question.
Yeah. Who's speaking,
So-
by the way? I'm assuming you.
Michelle.
Okay, hi.
Hi. So you mentioned that for every x, there can only be one y value, correct?
Yeah, yeah. Look, you
And-
can see right here, as this is an example right here.
Mhm. Then for every y, can there be 2 x values?
For every y, there could be 2 x values.
Yeah, like more than one x value?
Yeah,
Okay. So
but no, but we're not talking about, but that's the thing. If you look at the one side, you don't have to worry about the other side. So the key is looking at the independent. So let's go back to the beginning, because we're talking different types of variables, right? X is the independent variable. So the independent variable is the first coordinate. You can only have one value for, you can only have one dependent variable for every independent variable. Okay. So when we go back to here, here's my independent variable x -3, and I have only one particular y value. here is now my independent variable here, which is 9. But then it has a -3 as a value for a dependent variable and a 3. Doesn't work. So as I said before, this is not a function. You only have one y value for the x. So, and then into your answer, you got well, put it this way, look at the independent variable x. I should only have one y with it. That's it.
Okay.
Okay, so let me fast forward to where we are. So here we go. That's what the graphs look like. And I'm gonna fast forward a little bit. You can see that's not a because here's the vertical line test. You can see I draw a vertical line. I have my x's right here, but I have 2 different y values. Doesn't work. And when I do the vertical line test for a parabola, I only have for every x, I only have one y value. It only hits it at one spot. Okay. So let us fast forward this. He talks about it pretty much. Okay, so we can fast forward a little bit more. He's still talking about it. So I think we're getting into examples. Okay, so here's an example.
I'm going to go to this version. A vertical line test is simply a method for determining whether a relation is a function or not. If every vertical line intersects the relation at only one point, then the relation is a function. If you draw a vertical line and it intersects the relation at more than one point, it is not a function. So let's use the vertical line test to classify each of the following relations as a function or not. So if I take a vertical line and I pass it through this relation, notice that it only ever touches the relation in one spot. So
Okay, so we're not gonna, we get that, right? So we understand the vertical line test, right? If you look at this one here, you can see it's not, oops, I just want to make sure. Am I recording? Yeah, I'm still recording. Yeah, so you can see here, it's kind of very obvious. So I don't want to belabor the point. So we can fast forward that. This one is, if you look at it, it's not a function. This one here is a function. Right, only one. Now, this circle obviously is not a function. We can see that, right? It's simple, right? You got 2 points there. So we can fast forward that.
function. Next thing and last part of this lesson is you're going to learn how to state the domain and the range of a relation. So let's get the definitions out of the way. Basically, for any relation, the set of values of the independent variable, the set of values that x could be, is called the domain of the relation. The set of values that the dependent variable, so the y values, the set of corresponding values that y could be, is the range of the relation.
Okay. So what is domain? What is range, right? So let's look at that. Okay. Here's my graph. Okay. Oh, okay. So let's try this, right? And it talks about x. So let's go back to maybe color code that. So here's my x, here's my y. So the x deals with domain. Okay. Domain. And then the y deals with range. Okay, so when I have this line here going at this angle, my domain, is there any limit on my domain? If basically this line is going like this forever, is there any limit on my X? Just asking. Someone just shout out the answer or type it in the text. Is there any limit on my X? No. Is there any limit on my Y? Right? So you can see we got that, right? So it can be anything. My X can be any real number, and my Y could be any, and my range could be any real number. Okay. So let me back that up. Erase that. Go back to draw. Okay, so if I go like this, I don't know, I'll call that -2. Is there a limit on my range? Let's see. Okay. So I see some no's, see some yeses. For the ones that say yeses, what if there is, you're saying there's a limit. So the ones that are saying yeses, what is the limit then? Okay, so the ones that are saying that there is a limit, yes, the limit is -2. The range of this function, and the thing is, you gotta look, so the function is just, this is a function, right? Okay, that's the function, right? The range of this function is dealing with the Y. This function cannot be lower than -2. By the way, can you guys see my pen when I move it on the screen? Just wondering. Okay, good, because that helps me to understand if I'm showing you something. So you can see that this function goes all the way up, and it can't be, and if it goes all the way down, it can't be lower than -2. So my range is X is greater than -2. That's my range. Now, what about my domain? Is there any limit on my domain, which is the X? There's a limit on my domain. What is the limit then on my domain? Yeah, there's no limit. It can go forever and ever and ever. Okay. Either side of it can go forever, forever, forever. So if I were to keep drawing this all the way, all the way, all the way, all the way, and see at some point it's still going on my X, right? It's just gonna get bigger and bigger and bigger and bigger and bigger and bigger. It doesn't stop. Okay. So there's no limit on my domain for this, but there is a limit on my range. Okay. So let me continue with that.
Note, for a function for each given element of the domain, there must be exactly one element in the range, meaning for each x value, there must only be one corresponding y value for the relation to be a function. And we've talked about that a lot already. More simply put, domain and range. Domain, values x may take, range, values y may take. I'm going to show you just a little interactive activity here, just to maybe get you to be able to visualize domain and range. So I have a relation here, and for this relation, it only exists between 1 and 9. Most of the relations we look at are going to continue on forever, but for this one, it just exists between 1 and 4. So if we want to look at the domain and range, domain, we're looking at where does the function exist along the x-axis? Which x values could I plug into the equation for the relation, get a corresponding y value? So if I'm going to, so watch as this red.
Okay. So, well, I'll let him explain.
dot traces along the relation. The part on the bottom here, this yellow dot, is going to trace along the x-axis as I trace along the function, and that's going to tell me what the domain of the relation is. So if I trace the red dot along, notice, look at the yellow along the x-axis.
Okay, so basically your domain starts from here, because it's basically talking about the x, goes from here to here, right? So if we were to fast forward a little bit just to save some time, there you go. That is my domain, okay? Now for my range, it's also tracing, this thing is also tracing the range. It started from here, right? At this level here, and it went all the way down to here. So my range is 3 to 7, and on my y, and my domain on my x is from 1 to 9. Okay, that's all that is, right?
Goes between 1 and 9, and written in interval notation, which we're not going to do this year, but the domain is between 1 and 9 inclusive. The function exists for x value.
Okay, so this notation that we have here is called interval notation, and basically you're going to see this a lot in grade 12, okay, with square brackets and on either side, you're gonna have some round brackets. Okay, so this is how it was written, where it shows domain goes from 1 to 9, and the range goes from 3 to 7. Okay, what else is he talking? I think we can fast forward through that. Okay, so he's gonna talk about the general notation, and this is how you guys will write it this year. So general notation.
So let's go back and try a few examples of this. Here's the notation that we're going to use. So if we have a continuous function, we're going to write our notation like this. We're going to first say that x could be an element of real numbers. So a real number just means any type of number, rational or irrational number, includes integers, terminating decimals, repeating decimals, non-terminating decimals. It's basically saying the function exists everywhere along the x-axis, except this is a given that sign. This means given that we're going to have to state some restrictions on the domain sometimes. Maybe there's an asymptote somewhere and x couldn't be a certain value. Maybe x only exists between certain values, like in the example we did here, x was only between 1 and 9. So I would describe it this way and put a 1 and a 9 there, meaning x is always greater than or equal to 1, less than or equal to 9. If we have a discrete function, meaning the function only exists at certain points, we will actually write the x values of those points in our notation like this. We would just put x equals and then the values of the x coordinates of the points where the function exists. Same with range, but with range we're looking at y values. If we have a continuous function, we're going to write it using this notation. Discrete function, this notation. And we'll do some examples of this so you understand what I mean by these notations. And it's not too hard.
Okay, so let's get into the examples. Let's see here. Okay, so let's look at this one here, right? With this one here, you want to know what's the range, right? The range for these are ordered pairs. The first letter, my bad, the first number is your x, right? So I would look at all my x's, and my range would be, and how does he write it? Just showing how he writes it. My range is, and you write it from lowest to highest, okay? So my range is -3, -2, 5, and then 6. Okay. And then 7, my bad. No. -3, -2, Oh, -5 is twice, you only write it once, and then 6, okay? If you get something like that. Okay, my range is starts from the lowest to the highest, right? My lowest is what? -8, then -6, and then 3, and then 4, okay? I might have missed something there, but there you go, -8, -6, 3, 4, and 7. And then basically with this one here, my domain, these are just, so this is one way when it's in chart form, right? So my domain is X, which is age. And if someone's gonna say, how do I know which one's X, what I know is Y? Well, it's always done in that order, right? X comes before Y. Okay, you wouldn't put Y here and then X here, right? So 4, 5, 6, 7, 8. So you can see this is in order. This is easy, right? And then, but the range is different. The range, you have to look at it, it goes from lowest to highest. So the lowest was 5, the highest is, I believe, 22. And you go in between there. So now the question is, are each of these functions? Let's go back to the other one. Is this one a function? This is a function, right? Or no? If it's not a function, tell me why in the chat. What do we know about functions? For every X, you must have one Y. For every independent variable, you must have only one dependent variable. So again, is A a function?
It's not a function
Why?
because for 5, the dependent variable, it has two, or for 5, the independent variable has two dependent variables, -6 and 3.
There you go. Okay, perfect answer. Okay, so with this one here, they wrote it out already. And if we look at this one here, is this independent? Sorry, is this my bad? Is this a function or not? I'm checking the chat. This last one here, B, is B a function? I see some no's. Oh, I see more yeses now. Well, yeah, it's a function because for every age, there's only one number. Okay, I see age 4. I see number 8. Age 7, I see number 22. Right? Right? There's only one, for every X, there's only one Y value. Nothing's repeating. So yeah, there you go. So let's continue.
X values that are repeated. If there are any X values that are repeated, then it is not a function. Notice we have a 5 here and a 5 there. So when X is 5,
There you go. So let's go on to the next one. What did you say about that?
if we look at part B, there are no X values that are repeated. This one is a function. Part B is a function because for each element in the domain, there's exactly one corresponding value in the range. So for each X value, there's only one corresponding Y value. Let's go ahead and now practice a couple.
Okay, so determine the domain of each relation graph the relation first. You have to remember how to graph, right? How to graph lines. So that was a grade 10. That's a grade 10 thing. So I'm hoping we're in grade 11 functions. We know how to graph a line. Okay. So the main thing is, let me just write on the screen here. Okay, so this is my y-intercept. Okay, we're talking about how to graph this. So we're gonna go just a little lesson on graphing. Y-intercept, my 2 is the slope. Okay, So if I start graphing, I start at my slope, sorry, I start at my y-intercept. My y-intercept is -5, so 1, 2, 3, 4, 5. Okay, it's right there. Okay. And then I apply my slope to the point of my y-intercept. My slope is 2, so 2 is equal to 2 over 1. That's basically saying my rise over my run. Okay, so I rise 2, I run 1, right? So 1, 2, I run 1. There's my next dot. Rise 2, 1, 2, run 1. Okay, so I won't be able to draw this too good because I just know I'm not going to be able to, but basically, if I change the colors, my line is something like this, okay? And we already know it's a function. Why we know it's a function? Because I can just do my vertical line test, right? It's a function. It only hits at one spot, it's a function, okay? So that makes that easy. And he's gonna play it, so let's play it a little bit just to, there you go. He drew it where I drew it, and he's gonna do like a vertical line test. And you can see the vertical line test. So and then now the question is, what's the domain? Well, domain is you're looking at the X. There's no limitations on the X. It can go forever to infinity to the left, to negative infinity, it can go forever to the positive infinity. So there's no limits. So my domain, it's written like this: X can be any real number. There's no limits, any real number. And my Y, well now, sorry, my range is now dealing with Y. Now you're gonna look at it and say, well, there's no limits on my Y either. So on my range. So it's gonna be, oops, kind of fast forward. It's gonna be like any Y can be any real number.
The range is an element of real numbers as well. That basically means y could be anything. Let's do another relation.
Okay, so again, this is quadratic. And how is this written? It's written in vertex form. You guys remember vertex form, right? From grade 10. So vertex form. So it's when you have it in vertex form, it helps you to graph it. Okay. So let's graph it. Right? Because we need a graph in order to determine what is this. So the thing is in my way, I can't see, so move that out of the way. So my parabola starts at +3. So 1, 2, okay, so there's my origin. So 1, 2, 3 starts there. But it is on to the right by 1. So it's actually going to be over here. So that is actually my vertex. Okay. So that's my vertex. So my parabola is going to look like, and this is just a sketch, right? I'm not perfectly drawing it. It's going to look something like this. Something like that, right? And at that point there is +3, okay? And over here is 1, okay? So my vertex is 1 and 3. That's this point right there, okay? And that's based on my vertex form, okay? So what's the domain? What is the domain? What is the range? Well, domain, is there any restrictions on my X? Any limits on my X for this? I can't
No.
see if you get, oh, you guys are right in the chat, okay. Yeah, there's none, okay? So therefore, it's gonna be any real number. X could be any real number. But for my range, which is my Y, It's going to be any real number. Okay, like that's what we know, that it's going to be any real number. But now we have to write down here, what are the restrictions for, if there's any restrictions? And I think there is a restriction, right? We can see y can't be less than 3. So y is greater than 3. So the restriction we write in here like this: y is greater than 3. Okay, so it's any real number, yes, but y can only be greater than 3. And I should say greater than equal to. Okay. So that's what that is. Okay, so let me, I have that on the screen. Let me just clear it so we can watch the rest of that video. Oops, I'll clear that. And let me just fast forward. He's just drawing that, like I said. There is your domain, any real number. There's no restrictions. And then for your range, you can see can't be less than 3. Right? My bad, you put that line there, not the dots. And y is greater than 3.
Greater than
And
or
equal
equal to 3. So what this means, y could be anything given that y is greater than or equal to 3. Our next one, y equals the square root of x minus 1 plus 3. So if we want
Okay, so you have to graph this, right? Let's see here. Oops. Let me graph it first.
and we'd be able to graph this using transformations of that by shifting it right 1 up 3. But for now, maybe I'll just give you this graph and we'll look at what the domain and the range of that relation is. So if I'll give you this one and then I'll explain why.
Okay, so he gives it to us, right? And you can see, based on what we see there, the domain starts here. And then let me back up a little bit because he wrote something there. So in this function here, right? You see how it starts? There you go, this is a better view. It starts at x can be greater than and equal to 1. Why do you think that is? Looking at the function equation, why do you think that is? Why can't I have a number less than 1 for x? Anyone? Why can't I have a number less than 1? Look at that equation. Because things make sense once you see it and understand it. Okay, no answer. Well, if I had here x is 0, okay, 0 minus 1 is minus 1. Can I square root a minus? Can I square root a minus number? No, I cannot. That is the reason why x cannot be less than 1. If x is less than 1, then I end up square rooting a minus number. So x could only be greater than 1 or equal to 1. Right? If it's 1, then it's 1 minus 1, 0. Square root of 0 is a 0. It doesn't do nothing. Okay? So you understand that. Okay? And basically, the way this 3 is a Base-Layers transformation, it starts above the x axis at plus 3. So it'll never go below 3 as far as the range. Okay? So let us continue.
I have these answers for the domain and the range. So here's what the relation looks like. So right now you would probably have to graph this by making a table of values. And if we do that, we would get the relation that's in green.
Yeah, he's just giving us the answer because it's too hard to just graphing it any other way.
Here. And notice for this relation, I should draw my little arrow here. So this relation would continue forever in that way, but it will never be to the left of that point there. It starts here and continues off to the right forever. That's why the domain, it says x always has to be greater than or equal to 1. It's at 1 on the x-axis here. It'll always be at 1 or to the right. It continues off to the right forever, but it can't exist over here. Why can't it be to the left of 1? Why is there no corresponding y value for an x value of -1? Why doesn't the relation exist over here? Well, let's look. If I was to take this -1, this x value of -1, and plug it in up here, I would get the square root of -1 minus 1. That's -2 plus 3. And we can't take the square root of a negative number. We can't do it because nothing squared gives us a negative number. So we can't have a negative under a square root sign. That's why this relation does not exist over here. It only exists from 1 and over. That's why.
Okay, so let's fast forward. He's explaining what I just said. Let's go on to the next. Let's see what this is.
One. Oh, we'll do a couple more. Basically, so we have x squared plus y squared equals 36. That's a circle with a radius of 6.
You guys know this from grade 10, that's a circle, right? Circle formula, the radius is it 6? 6 times 6 gives you 36, so the radius is 6.
So let me just draw a circle here, centered at the origin. And hopefully you remember this from last year as well, with the radius of 6. I wish this wasn't lagging on.
Okay, so basically the radius of 6, and we know, basically looking at that, what the domain range is, okay? So the domain, looking at the x, he has to make it a little bit bigger, I believe. There you go. I think that's big enough. There you go. So my domain is from -6 on the x to +6 on the x. My range is from -6 on the y to 6 on the y. Okay, so that is my range, and that's my domain, right? So my domain is between -6. X is between -6 and 6, and y is between -6 and 6. Okay.
Notice this circle, this.
Okay, let's fast forward.
The last relation we're going to do is probably a brand new one to you that you would have never seen. It involves asymptotes. So if we're going to look at this relation, y.
Yeah, so asymptotes, you guys probably haven't seen it, but this is how it's drawn. So the curve is like this. You got two curves, like, well, it's one curve, right? So the asymptote is where the curve can get close to but can never touch. And that's because when you look at the equation, right, there is a restriction on what value you can have on the equation for x and y. Now, if we look at the x, if you made x -3, this means it would be 1 divided by 0. Remember, you cannot do 1 divided by 0 on your calculator, it's an error. So your denominator cannot equal to 0. So whatever value of x that makes the denominator 0 is your asymptote. Okay, so my asymptote is -3. So at -3, I draw a vertical line. I can never get to -3 on my x. It'll never. Either side, it'll just get really, really close, and it goes right up the asymptote line. Now the other thing is, I look at my y. My y, I can never get it to 0. right? My y will never be 0. So I'm going to say y. Well, I have 1 on my numerator. Automatically, if I have 1 on my numerator, for y to be 0, I have to have 0 on the numerator. Right now I have 1 in my numerator. So it's virtually impossible for y to equal to 0. I can have x equal to infinity. 1 divided by infinity will be a really, 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 really small number, but it's not 0. And that is it. So y can never equal to 0. So I have an asymptote, a horizontal asymptote at y is equal to 0. So now when I draw my curves go like, you know, from left to right. It can get really close to y. It can get really close to my asymptotes, but never cross. Okay. So let us see. Let's hear his explanation as well. That way it's kind of solidified in your guys' heads.
Y equals 1 over x plus 3. You're going to notice it has 2 asymptotes. I'll just really quickly explain what an asymptote is and why they exist for this relation, but we'll talk more about asymptotes later as we start graphing different rational functions, and you'll spend a lot of time with asymptotes when you take advanced functions next year. But basically, there is what's called a vertical asymptote, so an invisible line that our relation cannot touch. It can approach and get very, very close, but it will not touch. There's a vertical asymptote at x equals -3. Why -3? Well, if we look at our relation, if x was -3, if I plugged in a -3 for this x, I would have -3 plus 3 in the denominator. -3 plus 3 is equal to 0. So I would have 1 over 0. And you know that dividing by 0 is undefined. You can't do it. So there will always be a vertical asymptote at any x value that makes your function undefined. Okay, that makes the denominator 0. So there's a restriction for our domain. This relation exists everywhere along the x-axis except at -3. X cannot be -3. That's why I have
Okay. So x could be any number on the x-axis except for -3. So if I'm going this way, oops, I can't get to -3. I'm going to have to go all the way up. Oh, I'm coming this way. Oh, I can't hit -3. I'm going to have to come all the way down. Okay. Now it's going to talk about the y.
define the range as being x can be any real number, but it cannot be -3. There's an asymptote at -3 because if x is -3, it would make the denominator 0, and we can't have that. We can't have the denominator being 0. There is a vertical asymptote at y equals 0. So y equals 0 is actually the x-axis line.
Okay, he meant to say horizontal asymptote. There's a horizontal asymptote as y equal to 0.
There's a vertical asymptote there. Notice this relation, if we start at -1, it's going off towards positive infinity. But as we move to the right, it gets smaller and smaller and smaller and gets closer and closer and closer to 0, but never touches it. If we look at on the other side of the asymptote, if we start at this value here, notice it's going off to -infinity as it gets really close to -1 along the x-axis. And as we go to the left, it gets closer and closer and closer to 0, but never quite gets there. So there's a horizontal asymptote at y equals 0. And there will always be a horizontal asymptote at y equals 0 if the denominator of a function is a higher degree than the numerator. The numerator in this case is degree 0, the denominator is degree.
You guys missed that, right? I think he didn't understand what a higher degree is. And maybe you guys don't remember that from, so I'm going to see if I can help you with that. So higher degree. So when we actually looking at the degrees, oops, right? You remember when we go like this, x cubed plus x2 plus whatever. Maybe that's a little bit too high for you guys. Plus x, so equals to 0, right? The degree of this function is 3. The highest degree, right? The highest exponent is the degree. okay? But then if you have x to the power of 0, that's equal to 1, right? So technically, when you look at this is x to the power of 0, but you don't see it, right? But that's why it needs to be said. This is x to the power of 0, and this is x to the power of 1. So on the numerator, he said you're always going to have a horizontal asymptote, which is this. That's your horizontal asymptote, which is this, what you're getting here. X cannot, or y cannot equal to 0. You're always getting a horizontal asymptote if the degree on the denominator is higher than the degree on the numerator. Okay, in this case, the numerator, the degree is 0, right? It's a 0 because when you work it out, x to the power of 0 is still 1. So you're gonna have 1 up top, right? And then here you're still gonna have x plus 3, right? As a result, right, you're gonna have a horizontal asymptote, okay? Just wanna make sure. And also too, I said the other way where you can look at it and say, well, y can never equal to 0 just because there's nothing, your numerator is always going to be a 1. So that how can y ever equal to 0? Your numerator is always a 1. It's impossible, right? So just wanted to show you that. Let's continue. I think he's done.
Degree 1, the variable has an exponent of 1, 0, 0, 0, 0, 0. Vertical asymptote.
Okay, it's backing up. It's
If it
talking
never
about
touches. Explanation of why I talked about asymptote. Y could be any number. It's an element of real numbers. Given that y is not 0, y cannot be 0 in this case. And then here's just a little explanation of why I talked about asymptotes. An asymptote is a line that a curve approaches more and more closely but never touches. The function that we just talked about, y equals 1 over x plus 3, has two asymptotes. A vertical asymptote. We find vertical asymptotes by looking at where the denominator would be equal to 0. Because division by 0 is undefined, therefore the expression in the denominator of the function cannot be 0. So x cannot be -3, because if x was -3, the denominator would be 0. So we have to draw a vertical line at x equals negative.
Okay, so that is that lesson. Okay. This one here, I'm not going to go through. This is function notation. This video, I'll let you watch that on your own. We kind of talked about function notation already with how you write domain and range. This is only 13 minutes. Okay, so if I fast forward. Still talking about so you write. So one of the things, you know what? I know time it's past an hour, but we started a little bit late. So I'm just gonna play a little bit of this, and I'm gonna have you guys watch the rest of it on your own.
Course. This lesson's called Functions and Function Notation. So now that you know what a function is from last
This is only 10 minutes, but we'll just go maybe a couple of minutes of it.
lesson, we looked at different relations and determined how to classify those relations as functions or not functions. Now we're going to look at how to properly write functions using function notation. So function notation is going to look very similar to equations you've used in the past, with one key difference. Instead of having y equals something, you are going to have this, f at x, or f of x, it's sometimes called.
Okay, that's the key right there. I don't know if you guys seen that before, but this is how you write functions, right? Instead of writing a y, you replace y with f of x. Like that, f bracket x bracket. That tells you that your y is a function of your x, right? That tells you also my output of my y is dependent on what I make x's. So that's what this is saying, right? F of X, whatever that's going to be is dependent on what value I put for my X. Okay. That's why we call it F of X. Okay, let me fast forward a little bit. So that's why we talk about your independent variable is X and your dependent variable is Y. Okay, my Y depends on my X. In this case that we see here, right? My Y depends on my value of my X, right? That's what we're showing you here. So something to do with X, right? That whatever X is will determine what my Y is. Okay, so here we go, simple thing. Whatever, like, so we've done this before at some degree, I think. I think in grade 10, you just had Y. Now we say, no, it's gonna be F of X, and I'm gonna replace X with 2 in this question here. And then I'll have an answer for that, F of 2. Okay, so let's fast forward a little bit. They get into F of 2. You plug in the value of 2, so what? 2 times 2 minus 4. What? It's going to be what? 0, right? There you go, right? So that's what that is. Let me fast forward because I think you guys can figure that on your own. Right? You plug in -5 and you figure what that is. The function of -5. Okay, so let's see here. Now the next one is you plug in a half. X is a half, you plug it in and you write F of a half, and that's what you get. So now as a result, right, your Y, looking at this one here, let's look at this one here. Okay, let's look at that one. They're all the same. So this is my Y value, and this is, oops, my X value, right? My X value, I didn't write this, this looks weird. Okay, that's my Y, right? So if I plug in here, X, and then here is my Y, okay? Very simple. Okay, so.
X is a half. Let's do one more practice equation. This time we'll do a quadratic equation instead
I'm
of
going
a
to
linear equation.
cancel this.
So this quadratic equation, I think the first one we did was, we'll do the value of the function at 2, -5, and a half.
Okay.
So let's find the value.
I'm going to fast forward because this is just plug in values, right? So you guys can do that on your own. We don't need to do arithmetic on the screen like this. Okay, so you just plug in values. So I think, let's fast forward somewhere. Okay. I went too far. Let's see, what's the difference here? Okay. Here is a question here. This is a rational function. Let me just look at it.
And it's just basic arithmetic from there. Let's do an application of this. So I give you a function. H at t equals -3 times t plus 1 squared plus 5. So basically what this means is the height is a function of time. I believe that's what H and T stand for in this.
Okay, so this is where you have an application of how you have independent variables related to dependent variables. So in this case here, what's my independent variable? Is it T? Is it H? What is it? My independent. Someone is saying H. Someone saying T. Who wins? One of them is going to have to be the x-axis. So let's look at it again. Right? We know x is independent. And just replacing these letters here, you know, you have H and T, replace them. Which one is the X? Which one is the Y? You know, X is independent. You know, Y is dependent. Which one is the independent? T is the independent. So T will go along my x-axis, and H, which stands for height, is along my y-axis. Okay? So that's why we say H of T. Height is dependent on time.
This case. So first thing we're gonna do is graph it and find the domain and range. So you should recognize this is a quadratic function. So to graph it, I'd first start by plotting my vertex at.
Okay, so we're gonna just fast forward the graphing because we don't need to. There you go. See, T is on my x-axis, H is on my y-axis. So this is graphing it, so we're fasting forward the graphing. So now after you graph this, my domain is related to my x-axis. My x-axis is actually the time. Okay. Is there any restrictions on my x-axis? Someone say in the chat. Is there any restrictions on my x-axis? No, there isn't, right? So there's no restriction on my time here because time is independent. And if just not even just that, if you just look at the graph, you can see there's nothing here. But there is a restriction on my height, which is related to my range, okay? So it's written like that. Now we're gonna do the range.
Of the function. However, the range, remember we're looking at where does the function exist along the y-axis. This is the highest along the y-axis it ever gets, right there at 5.
Okay, so 5, my range is y is every real number, but my y is going to be less than and less than equal to 5. Oops. Okay, and I think we can stop there. Okay, I think we can stop there.
T.
Okay, so I'm going to show you what you need to do for today. Let's see. I need to look at, sorry, my bad. I'm gonna look at it from a student view. I want to make sure it makes sense from your view. I'm showing it from my view. So in the content section, you should have here a quiz. There you go. Here's the quiz. You can see it's due today. Under assignments, you should have, these are just worksheets to work on. The worksheets help you to understand. That way you can do the quiz, okay? And then under content, let's just make sure you can see properly. So this is showing everything, I guess. I didn't turn everything off, but you have your lesson for today, the video, the first lesson, the second lesson on notation, and then the 2 worksheets 1 and worksheet 2. Okay, and lesson 3 is inverse, which we're going to talk about tomorrow. Okay, so let's see, did we cover everything for today? I hope we did. Yeah, investigating notation, defining function. Okay, everything's there. I've finished both. Okay, I'm going to stop recording because it's getting long. Stop recording.